Okay, Akash. So today let us continue with our same chapter. So I think we are theoretically the total chapter is done. Yes. Now we are doing like last topic, that is mole and mole concept. Okay. Now yesterday I explained you some three important formulas. What are those formulas? Okay, so the first one is n is equal to m by capital M. Yeah, second one, n is equal to capital N by n naught. Is this? Yeah, what's the third one? Once again, small m is equal to small n into capital M. Yes, one more. Three only you are having. I think one more should be there. Okay, we see now in the as you are doing. So now in the last class, what we discussed is about the mole concept. Mole, it's nothing but it's a fixed number. The number of atoms, carbon atoms, the number of carbon atoms, C12 atoms that present in 12 grams of carbon is called 1 mole, and 1 mole is equal to 6.022 into 10 to the power of 23 entities. So whatever it may be, so the 6.022 into 10 to the power of 23 is called 1 mole. Okay, and this is also equal to Avogadro's number, right? So based on this, I explained you that the 1 mole mass of 1 mole of any atoms is equal to its atomic weight. The mass of 1 mole of any molecule is equal to its molecular weight. This also we discussed, right? Okay. So today now what we do, you do this sum. So now start, okay, read this sum, and by applying these formulas, you do this sum. Calculate the mass of the following: 1. 0.5 moles of nitrogen molecule, 2. 0.5 moles of nitrogen atoms, 3.011 into 10 to the power of 23 number of nitrogen atoms. Last one, 6.022 into 10 to the power of 23 number of nitrogen molecules. Okay. Now the first one, you see, calculate the calculate the mass. Calculate the mass of first one, 0.5 moles of nitrogen molecule. How can you do this one? Open your notebook, note down the sum first. Yes. Now first what you have to calculate is 0.5 moles. You have to calculate the mass of 0.5 moles of nitrogen molecule. So now how to do? First one, A bit, mass of 0.5 5 moles of nitrogen molecule. Okay. So will you do? Shall I explain one sum to you? So first you write what is given here. Given number of moles is denoted by small n 0.5, and you should know molecular weight. Okay, m of nitrogen, molecular mass of nitrogen N2, so that is denoted by capital M, is equal to how much? N is 14, N2 is 28. Okay, now they are asking to calculate the mass, question mark. Okay, now substitute here. We have a formula that what is the formula? N is equal to M by capital M. This is our formula, right? Now we want small m, so small m is equal to N into capital M, right? So N, how much we have here? 0.5 into capital M. Capital M is how much here? 28. So 28 into 0.5, 14. grams, that's all. Is it clear how to do? So similar way, go to the next one. Be some, first you do it in the in your classwork, in the notebook. Have you done this one? Second also done. Very good boy. What is the answer for second one? How much? 7 grams, huh? Right. Okay. Third one. Do the third one now. How we are doing the third one? For third one, what you do? Here you can see here once on the screen. We have to calculate the mass now. So write here mass is equal to N. But N is equal to, formula is what? Capital N by N naught, right? So in the place of N you write that one, N by N naught into M. This formula you apply, it will become easy to you. Three 0.01 into 10 to the power of 23. Cbit mass of 3.011 into 10 to the power of 23 number of nitrogen atoms they are saying. Okay. So now what's the formula I told you that? Formula I told that mass is equal to N by N naught into capital M. This formula you apply here. So then it becomes what? M is equal to N. N means what? This number 3 into, sorry, 3.011 into 10 to the power of 23 divided by n naught. N naught means what? Avogadro's number. 6.022 into 10 to the power of 23 into nitrogen atom, they said. Nitrogen atomic mass is 14. Yes? So now you can cancel here. 23 get cancelled. This ones are, this twos are get cancelled. So now 2 ones are, 2 sevens are get cancelled. So you get the answer is M is equal to again 7 grams only. This is your answer. In the similar way, the last one also you do. 6.022 into 10 to the power of 23 number of nitrogen molecules. How much?
28 grams.
No, 20 grams, right, correct only. Okay. So because that is 1 mole, no? So 6.022 into 10 to the power of 23 is nothing but a 1 mole. So 1 mole is correct only. Right, 28 grams. Okay, good. Now this question you do now. Read the question. Calculate the number of particles in each of the following. Okay, 46 grams of sodium atoms. Second one is 8 grams of oxygen molecule, and third one is 0.1 grams of carbon atoms. Here you have to calculate the number here. Here mass is given 46 grams, 8 grams and 0.1 grams. Mass is given and you need to find the number of particles you have to find. Number of particles. Come on, start doing. What is the answer for first one?
So we should calculate the number of moles, then we will calculate the number of particles.
Now you can do like that. Otherwise you can apply the same formula. Now till now what we applied the formula, this same formula also you can apply, I think. The same formula you can apply. See here, one problem I will do, the first one. So we need to find what number of atoms, right? So for this what you do, first take mass is given here. So first one I am doing, for first one M is equal to 46, so I write here 46 into I want number of atoms, so I'll put sorry, 1 minute. So that is equal to, okay, is equal to, here capital N is there, N is the number, I don't know, I need to find N only, divided by N naught, I know that 6.022 into 10 to the power of 6.022 into 10 to the power of 23, okay, into your molecular mass of the sodium is 23, yes or no? Atomic mass of this one. Now keep N here, you bring all this side, so this becomes what, see here I am doing here, so this is 46 into, now the denominator is going that side, so this becomes numerator 6.022 into 10 to the power of 23 divided by, see this into is there, so when it coming, it's come denominator, so that becomes 23, okay. So now see here, I'll cancel now, okay, 23 ones are 23 twos are, now I'll multiply, so 2 into this one, so this becomes 12.044 into 10 to the power of 23 molecules. That's all. This is the number of sodium atom that present in 46 grams of sodium atoms. Is this clear to you? Once you check. Remaining, by applying the same formula, you can do the remaining sums also. Now,
505 into 10 power 23.
which one?
Second one.
Second one, how much you got?
6.022 into 10 power 23 by 4 I got.
Oxygen is 16 to the 32, right? Okay, 32 weight is 1 by 4, correct only. So 1 by 4 of 6.022 into 10 to the power of 23. Good, correct only. Similarly, can do the third one now.
Sir, I got 6.6022 into 10 power 23 by 12 I got.
23 by
12, sir.
12. Okay. Now, okay, so take the screenshot of this one and these two sums and you practice at home. Okay, take the screenshot which have more number of atoms, 100 grams of sodium or 100 grams of iron. So here sodium atomic mass, you know, that is A is equal to 23 and iron atomic mass is 56. Okay, take the screenshot of this one and this sum also take the screenshot. Calculate the number of aluminum ions present in 0.051 grams of aluminum oxide. Right? If you do this one in the
100 grams of sodium or 100 grams of iron, sir.
iron, 100 grams of sodium and 100 grams of iron. So in which more number of atoms will be there. Okay? Okay. So with this we stop, and in the next class I am going to start the next chapter, chemical reactions and equations. So what you said? Yes, chemical reactions and equations I am going to start in the next class, right?
Okay, sir.
Okay then, bye. Take turns break and then have next class to you.